Hello, we have talked about if you want to understand something, to understand its referent properties, which you refer to something else, and its quantifying properties is also referent. But those referents are well agreed upon referents, like length and mass, time, and electric current, which is so-called four fundamental units. So let's examine what these agreed upon reference are about. So first, for length, you will have the meter, International Meter Stick, which is kept in the Bureau of International Students, whatever it is called. And I challenge you to find out what is this BIPM stands for. So, and that's meter. Okay, and also for the mass, you will have a prototype the weight, also kept in the same place for everybody to refer to. That's the mass of a kilogram. And for time, of course, you will have the one of the atomic oscillation frequencies and to refer to. So we'll get to that a little later on in this course. So now we have talked about in the class for meter, so that's the standard. We have meter stick. You can find yourself a meter stick to look at it. So how long is a meter? This is about this long, okay? Like a length from your chest to the fingerprint when you spread out your arms, when you open your arms. So, or you say as long as a guitar, and so that's, if you divide this one into 10 slices, okay, 10 pieces, and then that 1/10 of this meter is called a decimeter, which is tenths of meter, decimeter. And then if you divide this into 1,000 pieces, 100 pieces, excuse me, and then that is called a centimeter. So centimeter is about the width of, here we did the exercise in the class, this first exercise, and that, like you said, we repeat in the class, we have a class handout, we work on the exercises. Once again, you're not required to turn in exercise, but you are required to turn in the assignment. Actually, the first assignment is due next Monday. Okay, and then to understand something, to know its referent properties, which means referring to something else, or its quantifying properties, okay, and use a number and a units. That units is referring to, and we foregoing said, the three objects, like the meter stick, the kilogram prototype, and the seconds, which we have a special kind of atomic clock to define how long is a second. We'll get into that later down in this class. All right, so what is standard units of length, and which is meters that we talked to start. Okay, no, it's meter. Okay, is that meter stick? And then how long is a meter? So you can say, well, it's 10 decimeters or 100 centimeters, and 1,000 millimeters or 1 million micrometers. But since this is a physical science class, I would emphasize that you really relate to the units, especially the number, to the physical sense of what it implies. Okay, and you will say, I will ask you normally how long is a meter without using a number. There's, well, as long as a guitar, or the height of the table, or from your chest to your arm, and that's the meter. And that same idea, how long is a millimeter, which is a thousandth of a thousandth of meter, which means a tip of a pencil, and that's a decimeter, or width of your palm. And what is the standard? Okay, next, what is standard units of mass? All right, so mass is a kilogram. Okay, is 1,000 gram. A kilogram, if if we divide that by 1,000, it will becomes a gram. So on the other hand, reversely, if you divide that, you chop that little into equally, chop that prototype weight into 1,000 pieces, and each little piece will weigh 1 gram. So, right, so then there's another unit called millions. Once you millions, then you can milligram. So you divide a gram into 1,000, that's called a milligram. So then, what is the mass of a liter of water? And remember in the previous slides, we talked about if you use a decimeter to make a cube, and that will be a liter. Okay, decimeter to make a cube, that will be a liter. And then if you fill with liter, you make a liter into a box. You fill that box with water, and that water will have a mass of 1 kilogram. So that means 1 kilogram. So what is standard units of time? Seconds, right? So we'll talk about that. Now let's recapture what we talked about in the previous class. Kilogram weight is 1,000 gram. If you divide by 1,000, it's the gram. And also, one idea is that if you use a decimeter, which is 10 centimeter in size, to make a cube, and then that cube has the volume of 1 liter. If you imagine we make a box or container, bucket with and fill that with water, and that water has the mass of 1 kilogram. Nice, okay? Therefore, 1 liter of water is 1 kilogram. And then if you divide this box by, divide each of this box 1,000 times, so which means it is formed by this little tiny cube of 1 centimeter in size, like this corner, like this. And that is a milliliter. It's very small. Milliliter is about this tiny cube, and that is called a milliliter. And then so this liter is 1 kilogram of water, and this milliliter is 1 gram. Okay, 1 milliliter. That's very commonly used units. Okay, you see many times in the chemistry lab or lab technician use these tubes, and then these marks and says ml. That means milliliter. Sometimes they simply says mil to make it easy. We had a guessing game about just to get familiar with what is the commonly used mass units, grams. All right, we in the class we guessed what this mouse is. You get to hold this mouse in your hand, feel how many mass, how heavy it is, and then also you have a few of these little clips, paper clips, and that is about 1 gram. And then you guess, and this is the result. See, actually after the class we hear reviews, and then we put in here, and 72.3 glass. At the same time, we learn how to use this scale. To use this type of scale to weigh mass, you simply slide this slider to the very left, and first you try to see if it's more than 100 or 200, you move the big slider to the right place. In this case, you think it's less than 100, you leave this 100 slider there, and then you try to move the tens slider over here, 10 grams, and then until you see, well, it's between 80 and 70. So you stay at 70, is still the level over here is still going up, and then you slide this to 2 and 3. So therefore, if from here you can see it's 72.3 or something like that. So you see, actually Justin in the first session weighs 75, and also Kaylee weighs this. And those of you who are in online class like 801, you will get a chance too. So now, and this is a tennis ball. I have on the online a guess is the weight. Whoever gets correct, close, and wins. And after due time, I will weigh this. Of course, this is the game. Whoever wins will get 3% markup in next test. But you still have to make a good grade. For example, if you have only if you have 90%, 3% is 3 point more, and then you have 93. But if you only have 50 and then add 1 point, 1.5, you get 52, 55, and so on. So you still have to do it good, but there is a little help if you're on the borderline, 3% markup. And over the semester, I will keep on giving all this extra credit just to make you stay engaged with the class. So try to guess this one. So for everybody. All right. Here is another guessing game, the tennis ball. Did you guess correctly? And it's here. I weighed on the scale 56.94. In fact, you can measure things to as accurate as you can. Okay, use the scale, so 50 and then 6, so and then count 9 marks, and all these 3, 5, 6, 9. Okay, and 5, 6, and 9. They are all trustable, all solid, you can say. But then this little fraction part where there's no mark, you have to guess. That's called the last digit. In anything, not just the scale, and any scientific instrument, the last digit is typically a guess. Okay, it's the best effort guess. Okay, so now we will see who wins. The first, if two students are tied, you will get the same bonus, 3% raise in next test. So, having learned about the quantitative reference of the fundamental quantities like length, mass, time, and we didn't talk about electric current, but probably we'll not talk about it in this semester. And then there are actually two different systems, two commonly used measurement systems, commonly measured units. One is English units. Actually, it originated from Europe, most likely from England, and so they basically refer to some VIP's body parts like foot or something for the length, then pound or stone, etc. But now internationally we have more official called metric units system, international system of units. They are constantly being refined, and there are 7 standard units. Okay, for example, kilogram is one of the mass units, and meters is the length units, second is time units, and amps the electrical current units, and so on. Well, for quantifying properties, you need a number and a unit. So there are 7 SI units, that are units of international standard system of units. So 7 units, length, we have to talk about, and mass, kilograms, time, seconds, and another thing we will talk about a lot is temperature in the Kelvins, and define the 1/7 fraction of the thermal temperature of a triple point of water. And of course, you're probably curious about what is about triple point of water. Is at the point, and you have ice and water vapor coexist. That's a fixed point of temperature. That's actually 0 point of Celsius temperature. So that's temperature, and then amount of substance, it's called moles. We'll talk about that later. Luminosity, how bright the light bulb is. Okay, candela, okay, maybe related to candle, I don't know, cm, and electric current, actually, which is actually one of the fundamental units. Okay, that's end this week's lecture.